On the sketching, pull out your information, give me a sketch, set up your probability statement, the same setup that we had before. The setup that we're looking for is this. Set up your probability statement, sketch, use your mean, your standard deviations, go across the curve. If you realize you're only in the positives and you just want to do the positive side, that's fine. If you're only in the negatives and you do the negative side, as long as you give me some kind of sketch. Use your z-score formula to convert these x values to correspond to your z-scores. Determine your area. Your area is your probability. This is what's satisfying your statement when you do this. And you say x is greater than, less than, equal to, in between. This is what satisfies this, finding that area. So that's what we're looking at. That's the routine we're going to always follow. So we find a survey, and the survey indicates that for each trip to a supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes. So here we are, a mean of 45 and a standard deviation of 12. So let me say one thing. Last night, yesterday afternoon, we had our faculty meeting. In the faculty meeting, Ms. Jones, the guidance counselor, stood up and she showed us the average from NFA's students for SAT scores. We were above the SAT mean for the state. NFA alone was above the SAT mean for the state and for something else, I think the country. So we were slightly above. But what's more impressive, what she didn't say, was the standard deviation for NFA was smaller. I think it was like 12, where the state was 43. So it meant even more so because your standard deviation pushes you closer to the mean. More kids are coming closer to that average than are being spread apart. So this is how another way these are used, and when she said it to us, she looked at the mean only, but I would have even thrown the standard deviation in, which I'm going to talk to her because that's another good way to say, look at how much better we are doing as a high school if we are above the state average and the country average. But our standard deviation is even closer. So that's a good thing. And that's where you see these being used all the time. So we pull this information out. They have to tell us that this is normally distributed. So you're going to find the probability that the shopper will be in the store, and then if 200 shoppers enter the store, how many would you expect to do for each one of these? So for this guy here, we're going to set up our, God bless you. We're going to set this up right here. We're going to pull out your information. So what was your mean up there? And your standard deviation was 12. So let's set up your graph. We're going to use this for both. And what this means is this. Why would I want to know this? It's important how long someone's going to stay in my store. I'm the store owner. I want to know how long they're going to stay in there. If I have a lot of people overlapping and staying in there, I need more carts. I need more employees. If they're not staying that long and they're quick to go in and out, I don't need as many things. I need more items in my store. I need to know out of 200 shoppers, what amount of them are going to be in the store at the same time. Isn't that important? Absolutely. So I put my mean up here, and I add 12 all the way up. And then I subtract 12. Keep it going, right and left. Okay, did I get it right? Okay, now, probability statement. I need to know that what is between 24 and 54 minutes? X, good. These are my X values. So because it's in between, I put my X in between. I'm between. So it's always a less than, My smaller, my larger. How many? I need to know what is the probability that a random shopper will spend between 24 and 54 minutes at my store. Then I'm going to say, well, if 200 shoppers walked in now, how many of them would stay between 24 and 54 minutes? That's where that's important to me. I want to know if my store able to handle this. Do I have enough carts? Do I have enough employees to deal with this? Okay, so how do I go about doing this? Okay, so 24, somewhere between here, right? 54, somewhere between here. Is that a good chunk of probability? It's a good chunk of probability. Okay, so now I got to find my z-scores for these guys. So when my x is 24 and my x is 54, I find my z-scores. 24 says my z-score has to be negative. And I'm subtracting the smaller minus the larger. It is negative. I do the z-score for 54. Well, 54 says it's positive, and I subtract the larger minus the smaller. So even if you forget which way to go, your graph is going to tell you. Because if it's negative, subtract it so you get a negative. If it's positive, subtract it so you get a positive. So I get negative 1.75 and 0.75. And does that make sense? Am I between the negative 1 and the negative 2? Yeah. Am I between the 0 and the 1? Yeah. So what do I do to find my area in between those two things? I subtract my areas. Good. So I find my area for this guy. Here's the smaller area. I find the area for this guy. And I subtract. My area is always positive. Subtract the larger minus the smaller. That's the area in between here. Now, does that mean a lot to me, 0.7333? No. So if you turn it into a probability, into a percent, it's about a 73% chance that the person I take at random is going to spend between 24 and 54 minutes in my store. That's a pretty good percent. Now, if I have 200 shoppers walking into my store, this is my prediction, my forecasting tool. I want to know about how many of those will be in my store for 24 to 54 minutes. So I just multiply my 200 by my decimal. Okay, and remember to round. I don't know if I have this one. Let's see what 200 times. Okay, so 146.66 people. Do I have 0.66 of a person?
No.
No. Only when it comes to having 2.5 children. So I'm going to round this. I didn't quite get my 147. It depends how you look at this. You technically didn't get to your 147th person yet. So we really technically should round down. Later when we look at the less than and the greater than, we kind of round into your shaded area. So you're going to have to kind of use your graph a little. The in-between is a little tougher to do. All right, so we took a look at your probability statement, finding your z-scores, finding your areas, taking the difference, and then finding what would happen if out of 200 people, 146 of those people are going to stay in my store between 24 and 54 minutes. That's a good amount of people to be standing in my store. Going through the aisles. Do I have enough food if I'm a food store? You know, do I have enough baskets? Do I have enough checkouts? You know, those are things I want to look at. That's important. If I only find 10 people staying in my store that long, I maybe don't need as many carts, don't need as many employees standing at the checkers, right? It's a little bit less. Same situation. Now I want to know what's the probability that they will stay in my store more than 39 minutes. Again, this is my x. X is my random variable about how many minutes are they staying in my store. If I pick a random person, what is the probability that that one person stays in the store for more than 39 minutes? So I've got my graph. I can see where 39 is. 39 is over here somewhere. Which way do I want it? To the left or to the right? To the right. So should my percentage be less than 50% or more than 50%? Right? More, because I'm here between the 0 and the -1. This is 50% right here. When I look up this number, I'm going to get a number less than 50%, which means then I have to do what? Subtract it from 1. Okay? So we're going to find your z-score. Is my z-score going to be positive or negative? Negative, because I'm on the negative side. I should subtract my x minus my mean, my smaller minus my larger. And I should get a z-score of -0.5. Now, when I look up my -0.5, I get a number less than 50%. But I knew this had to be greater than 50%, so therefore I subtract this from 1. That's why your sketch is so important. It really, really makes sense. So I have about a 69.15% chance of this person that I selected staying in my store for more than 39 minutes. And again, if I had 200 shoppers, I would take 200 times 0.6915. I don't think I have that one either. God bless you. So I would expect 138.3 people or 138 people. Now, here is the difference here. You still really need to keep it to your own person didn't get there yet.
Do you always round down?
Well, in the terms of how many people, yeah, because you didn't reach your other people yet. In the terms of when we do the x values, then we'll have to look to see where does our shaded area fall. If you want them in the more than, they've got to fall to the more than. But in terms of the number of people, yeah, we didn't reach that extra person yet. Okay, does this make sense? So, again, we are at 45. Let's just write this down here. Okay, we're at 45, and our standard deviation was 12, right? So we are at 57, at 69, at 81, at 33, at 21, and at 9. So your probability statement says between, okay, with the probability that the shopper is not your z-score, your shopper is your x. They were between these minutes. So start like this, between 33 and 60. Okay, so therefore you want between 33 and 60. So again, you want a good size. So you're going to find your z-score, God bless you, for 33, which tells us it is negative. Sorry. And then you're going to, and I don't think I have this one. Yeah, I do. I tried to make sure I had all the things worked out so I wouldn't have to stop and work them out. And sometimes I ask and nobody answers me. -1, thank you. Then I do a z-score for this guy, and this guy should be a positive, and it is the larger minus the smaller. And this one is 1.25. Now, do not subtract your z-scores. Subtract your areas. So find your area. And again, area has to be positive. Subtract the larger minus the smaller. So there's about a 73% chance that the next shopper that walks in my store is going to spend between 33 and 60 minutes. Okay? Make sense? Now, let's pull this up on the calculator. Remember we were finding your z-scores. Whoops. We were finding your z-scores, and we had to use your 0 and your 1. We did this once before. I'm just going to move this here because I think it works better on the right side of my thing. We'll see. So, second VAERS. Now, I know my lower limit. Use your X values. My lower limit is 33. My upper limit is 60. Watch, guys. This is going to bypass a lot for you. I need to use, because I'm using my X values, I need to use my mean and my standard deviation. I don't want my z-score. I want my area. So you come down here and you paste. Isn't that what we came out with? Pretty close to it? Don't forget we've got rounding. We had to round our z-scores. We had to round our areas. The calculator is far more accurate than we are. We've got rounding in there. Okay, so this is a nice way to do it. And bypass all of this. If I only want to know what the probability is, there's your probability. Just round it to 4 decimal places. Remember, when you're using your X values, you're using a mean and a standard deviation. If we go back to the one before this with the 39, let's pull this guy up a second. If I'm going to do the one with the 39 in here, oh, there it is over there somewhere. Okay. Second, theirs. Come down to number 2. My lower limit is 39. That's my left-hand bracket because I want more than. This is where it makes a difference what you put in your limits. Well, your negatives you probably will never use, but your positives. If I just put in 99, it's very possible I could hit a 99 because look where my numbers are. And so I want to make sure I get enough 9s in there. Like, say my numbers were 3,900. I can't use 999, right? So just, think about it before you put that in. And again, same thing, goes in, you paste, and it does all your subtracts for you and everything. There's your answer. 6915. There's your answer. It does your subtracts, it does everything for you. It does your z-score and your areas. I usually get half the kids like the formulas, half the kids like the calculators. And some like the calculators just to check. I mean, I happen to be a formula type person. I do like the calculator, but I always show the formula for those that like formulas. So you'll always see me doing the formula up here. Are we good with this? Anybody have any questions on this? Okay, this is your homework.